Good afternoon, class. Here's exam 4 review, chapter 4, application of differentiation, chapter 5, integrals, 6.1 area between curves, and here's part 4, covering 5.4 and 5.5, 5.4, indefinite integrals and the net change theorem, 5.5, the substitution rule. So here's the net change theorem. Also, we've looked at it as FTC, the integral of f of x dx from a to b, or the integral of capital F prime of x dx from a to b is f of b minus f of a. In other words, find an antiderivative of this expression, f of x, and then evaluate it at the endpoints, their difference, f of upper limit b minus f of lower limit a is the answer. This is also known as the net change theorem. So what we are looking at now, this concept of an indefinite integral is the same as anti-differentiation, okay? And if we wanted to differentiate this expression, we would do the same thing. First, we would change the square root of x to x to the power of 1/2. Then we would make up two fractions. This has exponent 1. The bottom has exponent 1/2, so 1 minus 1/2. For the first one gives you x to the power of 1/2, and the second part is x to the power of negative 1/2. We do that so we can use the power rule on that. So this one would be 1 over 1/2 plus 1 x to the power of 1/2 plus 1. This one would be 1 over negative 1/2 plus 1, or x to the power of negative 1/2 plus 1, and a constant. Now, this part, this is 3/2. So when you divide by 3/2, you get 2/3 x to the power of 3/2. Okay. So you get 3/2. Negative 1/2 and 1/2. 1 is positive 1/2. So this gives you 2/3. This gives you 2 times what you see in this case is x to the power of 3/2. In this case, x to the power of 1/2 or square root of x. And that's the final answer. A bacterial colony increases at the rate of R of t equals 2.2 e to the power 0.4 t bacteria per hour. If the initial population is 800, find the population after 12 hours. So we are going to explain what is given. Let capital R of t represent the population, and R prime, capital R prime, is the same as lowercase r of t, represents the rate, the growth rate. And of course, this is R of 0. And according to the accumulated change, the amount of increase over the course of 12 years is the integral of R of t dt from 0 to 12. So we're going to replace the R of t and for the integration, we're going to divide by 0.4. We don't need the constant because it will cancel out. The ratio of these two, 22 over 4, one way to write this is 22 over 4, or 5.5. At this point, you have to plug in 12 and then plug in 0, subtract them, and we end up with 662.81. And we go with 1 decimal or 2 or more. However, so we have to pay attention to the given. However, since it refers to a size of a population, we have to go with the whole number and we round it accordingly. That's why we change it to 663. But you really want to show what you have to begin with and then how you end up with that number because it's rounded accordingly. Now, the initial population is given as 800. So what is R of 12? You have to add the initial population, okay? Because this is the amount of increase class. This is the amount of increase. This is the amount we had. They add up. Now, here's the second method. And the second method is to integrate this. We already know how to integrate this. The answer is 5.5 e to the power 0.4t, and we add a constant. Since R of, and so that's 5.5 e to the power of 0.4t plus a constant. That's capital R of t, okay? So what happens is, we know the initial value is 800. C becomes 794.5 because if you replace this one, so let's R of 0. If you replace this one with 0, you get 800 equals 5.5 e to the power of 0, which is 1 and a constant. And I hope you see that from here, we can get to this answer. So it's very straightforward, everybody. All right, so let's write it. This is the formula in general. What is the advantage of this? You want R of 12, you plug in 12. You want R of 10, you plug in 10. You want R of 15, you plug in 15. So that would be the advantage of that. This will give us for one point in time, which is 12. This will give us a general solution. At any given time, you just replace the t with whatever they give you. The integral of sine 2x over sine x dx, there are different ways of approaching it. The best course of action is to replace sine 2x with 2 sine x cosine x. Remember sine of 2 alpha, right? And these two cancel each other. We get 2 cosine x dx. You know the derivative of cosine is negative sine, but the integral of that is positive. So positive 2 sine x plus a constant. And again, we have it here. All right, notice this is 1 over x. Let me write that in case. If you see that, you don't have to write it, but if you don't, rewrite it in this fashion, so you know the answer is a natural log. The reason I didn't put the absolute value because the endpoints, the limits are both positive, otherwise you must. So it's ln of 6 minus ln of 3, which is ln of 6 thirds or ln of 2, and that's an exact answer. You can leave it like that. Exact answer, everybody. Exact answer. Many fish grow in a way that is described by the von Bertalanffy growth equation. For a fish that starts life with a length of 1 centimeter and has a maximum length of 30 centimeters, this equation predicts that the growth rate is 29 e to the power minus x centimeters per year, where x is the age of the fish. How long will the fish be after 4 years? Rounded to 1 decimal. We let capital L of x represents the length of the fish at any age x. Then the growth rate, that means L prime of x or dl dx is this number, this function 29 e to the power minus x centimeters per year, with the initial value being 1. L of 0 is 1. So according to the accumulated change theorem, the amount of increase requires the integral of this piece, of course, times dx from 1 for 4 years, from 0 to 4. And it's a simple case. 29 divided by -1 makes it negative 29 e to the power minus x from 0 to 4. First you put 4, then you put 0. And class, you just have to use the calculator. This is 1, easy, but this one you have to put it in the calculator because they want an approximation with 1 decimal. They don't want an exact, of course. And on purpose, I'm using more than what they asked because I want to show you how you do the rounding accordingly. First of all, L of 0 is 1, and it must be added to that. Secondly, this one, they want 1 decimal. So 4 next to the 6, it goes up to 5, 28.5, and 1 is 29.5 centimeters. And again, I'm going to show you the second method as it was discussed in another example. And that is, if we have this one as negative 29 e to the power minus x from 0 to 4, then L of x in general is the integral of that, which is negative 29 e to the power minus x plus a constant, and L of 0 was 1, right? So we are going to use L of 0, which means one is no negative 29 e to the power of minus 0, or 0 makes no difference, plus a constant. As you know, this is negative 29 plus a constant, and constant becomes 30. C is 30, everybody. So now you are going to replace the x with whatever number they gave you. And again, what is the advantage of that? The advantage of that is that if you want the length at 4 years, 5 years, 10 years, just replace the x. And I put it with more decimals just for illustration, okay? But with 1 decimal, this is the answer clearly. A particle moves along a line so that its velocity is given as v of t equals t squared minus t minus 6, measured in meters per second. Find the displacement of the particle during the time period 1 to 4. So displacement by definition is the integral of a to b v of t dt, whereas distance is the absolute value of that. Okay, so I want you to see this concept here. As we go from T1 to T2, this area plus this area plus this area would be the total distance. But as far as displacement, this area plus this area, and this is negative minus this area. To make more sense out of that, if you move from point A, everybody, to point B, this is your displacement. But the distance, the displacement. But if you went zigzag this way, that way, this way, that way, this way, that way, this way, until you got here, your displacement is the same thing. It's A to B, but the distance you covered is this, plus this, plus this, plus this. All of those you have to cover. That's the distance. But you just went from A to B. So displacement versus distance. So basically S of 4 minus S of 1. So that is the displacement formula. Just take the integral of that. The v of t, plug in. As you know, this is 1/3 t cubed minus 1/2 t squared minus 6 t. Now you're going to plug in 4, you're going to plug in 1. Quickly, I will show you, but you know, everybody can calculate this. So what you have here is 4 cubed over 3 minus 4 squared over 2 minus 6 times 4 minus, okay, 1, you cube it or square it, makes no difference, 1/3 minus 1/2 minus 6. You do that, you end up with negative 9/2. I'm going to leave it for you to evaluate this, okay? Negative 9/2. What does it mean? It has moved 9/2 of what? Meters towards the negative side, towards the left side. So let me erase the mess. That's the meaning of it. So the particle moved 4.5 meters towards the negative side, which is the left side in this case. We want to find the distance. To find the distance, we have to use the absolute value. In essence, it means, again, I want to make sure we understand, this plus this minus this one is part A. Now this plus this is part B. That's the concept. And so to know what you have to do, when it's positive, you keep the v of t unchanged. But if it's negative, you have to put the opposite of that to make this positive, okay? So you have to do a sign graph on that. So first and foremost, we are going to factor this expression into t plus 2, t minus 3. Use a sign graph. So t is going to go from negative to positive infinity, although t is just time. So from 0 to infinity, okay, class. But even if you go in general form, again, please understand, we're going to go from 0 to infinity. Let me just actually. So really have to go from 0 to infinity. So what we are really interested in would be both sides of number 3, to the left and to the right of it. So if I pick TP short for test point, and I go with, let's say, 0 on the left side, and let's say 4 on the right side of number 3. That's all we want, number 3. And by the way, they will alternate, okay? At a negative 2 V0, at positive 3 V0. So if you plug in 4, and it may be easier that you put it here, 4 makes this one positive, positive, the product is positive. You don't even have to calculate, it alternates, negative here, positive here. But if you put, for the sake of argument, to the left of 3, if you pick 0, makes it negative. So you have those signs. So what does it mean? From 1 to 3, because we are going to go from 1 to 4, okay? From 1 to 3, we are going to use the negative of that to make it positive. From 3 to 4, we use the v itself. So a negative of v of t, so minus t squared plus t plus 6dt, and v of t itself. So these are two pieces. You have to evaluate each one. And again, I'm going to leave it for you to do that. This is negative t cubed over 3 plus 1/2 t squared plus 6t from 1 to 3. And this one, half of 1/3 t cubed minus half of t squared minus 6t plus 3 to 4. And I'm going to leave it for you to do the math. You plug in 3, you plug in 1, you plug in 4, you plug in 3. And it ends up giving you precisely 61 over 6, or about 10.17 meters. So the distance covered is 10.17 meters. Again, the difference between the value of a definite integral and a total area. So what we had in essence in the previous page, total area versus the definite integral. Definite integral represents the signed, you know, areas or the difference of areas. So find the area between the x-axis and the curve y equals cosine x, and that means we want this area, and we wanted this area, and let me use actually a different color for that. And we want to add them up. When it says area, let me use a different color. And these two areas, you want to add them up. So that means the absolute value of cosine. That's the meaning. And you don't have to do the sine graph because clearly it's positive here. So from 0 to power 2, we use cosine. But since it's negative here, we're going to use the negative of that, the opposite of that, from power 2 to 3 power 2. This gives you sine x. Remember, the derivative is negative, but the integral is positive sign. So sine x from 0 to power 2 minus, because of this negative sign, minus sine x from power 2 to 3 power 2. So plug in power 2 and then 0, minus plug in 3 power 2 and then power 2. So this area, the plus area, if you will, that is 1 minus 0. And this one is minus 1, minus 1. Okay. So this is positive 1, everybody. Pay attention to this. This is positive 1. This is negative 2. But this negative makes it positive and gives us 3 because we want the area. However, what is the value of the definite integral, where we don't have an absolute value? Then this is considered as positive 1, and this is considered as negative 2. You add them up, you get negative 1. If you do the math, sine x from 0 to 3 power 2, you get sine of 3 power 2 minus sine of 0. You know 3 power 2, the sine is negative 1. And that's what happens. In other words, this area minus this area in essence. And I can't emphasize this enough. It's very straightforward, everybody. Okay. Let's move on. In the concept of a substitution. Integration by substitution is the reverse process of the chain rule in differentiation. So if I want to differentiate this, capital F prime of g of x times g prime of x. And it normally does that if we represent capital F prime with lowercase f, then this can be replaced by lowercase f of g. And that's all there is to it. So if this is the case, the integral of this one, the integral of this right side, of course, with dx is this. That's all. To make life easy, we let g of x to be represented by g, and of course, the derivative of that, du dx, du dx is g prime of x, and du is g prime of x dx. So we can rewrite the whole thing as follows, everybody. The integral of f of u du is capital F of u plus a constant, or capital, and then replace it, capital F of g of x plus a constant. So it means over any interval for which u equals g of x is continuously differentiable and f is continuous on the range of this function, the following relationship holds. The integral of f of g of x g prime of x dx This is g of x. This whole thing is g prime of x dx or du is equal to integral of f of u du, capital F of u plus c, or capital F of g of x plus c. So this is the reverse process of the chain rule. That's all there is to it. So, for example, we want to differentiate this, and we want to integrate this using the substitution, and here's the tip. Look for a function u equals g of x anywhere in the integrand, and its derivative du or g prime of x multiplied by dx. When you have a bunch of polynomials, the one which is more complicated is the choice of u. So x squared plus 5 would be the choice of u. So du dx is 2x, and du is 2x dx. And again, let me write that just to make sure we remember this concept. Class du dx is 2x. And then du is 2x dx. We're going to move the 2x next to dx so everybody can clearly see that this is du. So we have u to the power of 30 du, and that is a simple case of a power rule, 1 over 31, u to the power of 31 on a constant. And we're going to replace the u, and we are done. All right, let's look at this example where we don't have to do much. It's just anti-differentiation. Pay attention to the fact your independent variable is theta. So 5 doesn't give you 5x. 5 theta, cosine the derivative is negative sign, but the integral is positive. So it's positive 2 sine theta and a constant. And you're done. Anytime you have e to some power exponential functions, most of the time it is the exponent that is the choice of u. So if you choose that to be u, then the u is 5x to the power of 4 dx. Now, what most texts do, they solve for dx. I want you to pay attention to the easy way that I'm going to show you. I'm going to move x to the power of 4 to dx, and the first thing I notice that I have everything except number 5 there. Because 5 is a number, I can do that. If it's not a number, I can't. If it involves variable, I can't. A number is missing. So if I plug in that number, how do I undo that? With its reciprocal. When you put the number here, you have to put the reciprocal in or outside. The integral sign makes no difference. Their product must be 1. So if I have 10, 1 over 10. If I have 2, 1 over 2. If I have 2/3, 3 halves. And now we are looking at a simple case of e to the power of u. The integral is itself. So 1/5 e to the power of u and a constant. And now you replace the u. And if you have any doubts, you want to differentiate the result, it must give you this one without the dx. All right. Anytime you have a rational function or even a fractional function, meaning it doesn't have to be a rational function. Remember, rational means the top and the bottom are both polynomials. The very first thing you're going to ask yourself, can I simplify? If you can, you must. If you cannot, then forget it. And because the numerator has a factor of 4x plus 1 and nothing else, and this doesn't have a 4 here, even if you factor, it doesn't change anything. So forget it. It can't be simplified. So we move on to the next step. The next step is denominator is a choice of u. If you differentiate that, you get 4x plus 1. So du is 4x plus 1 times dx. And we're going to put the dx at top. So we can clearly see we have du over u. So the integral of du over u, by now everybody knows it's the natural log of u and a constant. And you're going to replace the u and you're done. Now, pay attention to the fact that we need the absolute value. And if you know for sure this expression is positive, you can drop the absolute value, which of course depends on the value of b squared minus 4ac. In any event, this case, I want you to notice that the top, I can take the 4 out, gives me 4 times x minus 1. I can do the same thing with the bottom, having x minus 1, and I can. That makes life easier. So this I can't factor. This one I can. Both of them have a common factor of x minus 1, and I must. If I don't, I won't end up with the correct answer. Okay. So now we have that. Now, if we choose u to be the denominator, which is 2x plus 3, du is 2 dx. So what do we have up here? 4 dx. So we write it as 2 times 2 dx. Please, class, pay attention to the fact. 4 dx, I'm going to write it 2 dx times 2. Now, I put the 2 outside. It doesn't matter out or in. It's a number. So what you're looking at is now du over u, which is the same as this one, natural log. Don't forget the 2. And replace the u. And as always, you can check by differentiating the result. You can check by differentiating the result. And we're done. Now, here's the interesting part I want everybody to pay attention to. And that is, again, seeing it side by side. If I use the reciprocal of b, then I'm not going to show you. I'm going to factor out x minus 1, and I get the reciprocal of that, 2x plus 3 over 4 times dx. I'm assuming you can follow the math. Now I make up 2 fractions, meaning half of x here, 3/4 here. There is no need for a substitution. As you know, x gives you half of x squared times 1/2 is 1/4 x squared plus 3/4 x plus a constant, and you're done. So seeing all 3 side by side, this can't be factored. This can be factored. This one doesn't need a substitution. So look at all 3 questions side by side. It would be extremely helpful to see why it works the way it works. Again, we are looking at 2 fractions. The first one is a transcendental function. The next one is a rational function. It doesn't matter, just fraction. The first step, can I simplify it? The answer is no. Use the denominator as a choice of u. So what is du? E to the power of t dt. Put the dt at top so it becomes clear that you have the integral of du over u. It becomes clear that you have the integral of du over u. I can't emphasize this enough. Well, you know it's du over u, and you know it's a natural log. Replace it, and you're done. It's that simple, everybody. Now, if you remove the absolute value, it works because the expression is always positive. The expression 5 plus e to the power. Part B, we can simplify it. You can try it. B squared minus 4ac is negative, and therefore it can't. So you choose u to be the denominator. Now, if I differentiate that, let me show you. So this one, du dx is 2x plus 2, or 2 times x plus 1. Therefore, du is 2 times x plus 1 dx. And I'm going to rewrite the expression such that dx is at top. Remember, dx is always at top. It will never, ever be a part of the denominator, or it's wrong. So when I look at this, clearly number 2 is missing, everybody. Because it's a number, I can put a 2 and 1/2 to undo that. Their product must be 1. You can only do this to numbers instead of solving for dx. This is the faster way. So you're looking at du over u, which is a natural log. And replace the u. And there you have it. And you must keep the absolute value, because this expression can be positive or negative. Again, I want to look at this, which is the reciprocal of part A, again on the same page. That makes a difference when we look at it that way. So this fraction, 5 e to the power minus t, this fraction is plus 1, and I don't need substitution method. So 5 divided by negative 1 minus 5 e to the power minus t plus t, and a constant, and we're done. No need for substitution, everyone. The key being understand what you're dealing with. For this case, you're dealing with a fractional expression. You can't get away from it. For this one, it's a fractional expression that you can get away by making up 2 fractions. What I want to do for this one, I want to look at it from the point of view of others and the text that solves for dx. And also I want to look at from the point of view of me, what I may explain, which is the easy way out. Number 1, you let u be 3x plus 7, and du is 3 dx. If you solve for dx, you get dx equals du over 3. So the integral 3x plus 7, we are going to replace it with u, and dx, we're going to replace it with du over 3. Now, this is simple enough that really doesn't make that much of a difference between this method and the method that I do. What is the method that I do? Is that I write, and that is, by the way, 1/3 of u to the power 1/2 t, right? 1/3 u to the power 1/2 t. The way I do it, I say, well, I have the square root of u, I have the dx, but here's the dx that is missing. Number 3 is missing. So I throw in number 3 and I undo that. I hope you see that. So I throw in number 3 and then I do that. Then I undo that. So I think it's pretty straightforward, right? And that's the same methodology. In this case, did they make much of a difference because that's a very simple case. So 1/3 remains. This one 1/1/2 plus 1 u to the power 1/2 plus 1 and a constant. All you have to do is simplify this, and let's do that. This is 3/2, which makes this 2/3. So 1/3 times 2/3, u to the power of 3/2 and a constant. This is 2/9. Replace the u with 3x plus 7, and you're done. I want to get the last question of this part, which is interesting. I am given f of x equals 4e to the power of minus 0.2x, and I'm asked to find the derivative of the function and the integral of the function. So I want to make sure we understand what's going on here. So to differentiate 4 times minus 0.2 e to the power of x minus cosine x. So what do? We multiply by the exponent, by the coefficient of the exponent. And we get negative 0.8 e to the power minus 0.2x minus cosine x. If I want to integrate, I have to put a dx next to it, dx next to it. And as you can see, for the differentiation, we multiply by k. For the integration, we divide by k. So 4 divided by negative 0.2 e to the power minus 0.2x minus the derivative of sine is cosine, but the integral of that negative cosine. So minus negative cosine or plus cosine and a constant. So again, 4 divided by negative 0.2 e to the power of negative 0.2x, and then minus sine x gives us plus cosine x. This one is 4d divided by negative 2 or negative 2. And one more thing now to add. What if we make this into an initial value with f of 0 being 2? In other words, we are given the pair 0, 20 to go from a general solution to a particular solution. So let's replace the x with 0. 0 here, 0 here, and f of x with 2. As you know, this is 1, so we have minus 20 plus cosine of 0 is 1 plus c equals 20. And I hope you see on the left side we have negative 19. We move it to the right side, becomes positive 19, and 20 is 39. C is 39. And now this is a particular solution. Now, this was a general solution, a family of functions. This is one solution, one of those solutions, because a pair is given.